Welcome. Inequality is one of examiners' favorite topic of them all. They can appear in higher or foundation GCSE math exam paper every year. That's what makes this one of the most important topics that you must know in order to pass your GCSE math exam. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. Inequalities are all around us. For example, according to current UK law, you must be 17 or above years old to be able to drive car on the road. In this swimming pool, children under 8 must be accompanied by a competent adult swimmer. This game is rated 12 or over, which means it's not suitable for people under the age of 12. In maths, we love shortcuts and abbreviations. This is because it helps us to avoid writing long sentences and we can work much more efficiently. For example, the statement that children under 8 must be accompanied by a competent swimmer can be abbreviated to age less than 8, where this symbol represents less than. We can go even further by denoting the age with a letter A and write this statement as A less than 8. Inequality symbol in this case is akin to hungry dragon trying to eat the large number. On this occasion, children's age must be smaller than 8. So it goes on the tail side of the dragon and 8 goes to the mouth side of the dragon. This means the children aged less than 7 and those who are in between aged 7 and 8 are also included to be accompanied by a competent adult swimmer. In the other hand, if we want to write ages more than 8, then the dragon's mouth will have to face to the left side. Note that we might refer this as 8 is less than age as opposed to age is more than or greater than 8, as they mean the same thing. However, generally we prefer to say that the age is greater than 8. If you wanted to say game is rated for age 12 or over, we can simply write this as age is greater than or equal to 12, where the inequality symbol denotes more than or equal to, or just A greater than equal to 12, as age can be abbreviated to just A. This is the same as greater than sign, but extra little line is added to account for the equal to statement. It means that the game player can be age of 12 or over. Similarly, people who can drive are aged 17 or over can be written as age greater or equal to 17. It is also possible to show inequalities on a number line. Suppose you want to show A is less than 4 on the number line. This is simply shown by a line and a circle like this. This shows that A less than 4 is all the set of numbers that lies below 4 and 4 is not included. However, if the circle is filled, this denotes that the 4 is also included in the list and it shows the number that A is less than or equal to 4. Similarly, in order to show that A is more than -3, we draw a circle on top of -3 on the number line and we draw the line going to the right. If -3 is needed to be included in the solution, then we fill the circle and this shows that the A is greater than or equal to -3. Compound inequality combines multiple inequalities into one, and it is often connected by the word and or. We can represent compound inequality in a single number line. For example, in order to show this inequality on a number line, we may start by writing the inequality A is less than 4 on the number line. And we can show that A is greater than -3 on the same number line by drawing another line, A is greater than -3. The connective word and indicates that both the inequality A less than 4 and A is greater than -3 must be satisfied at the same time. This can only occur between -3 and 4. This is the intersection or the common values between the two inequalities. Hence, we can start with the open circle at -3 and 4 and join them with a straight line. Both number has open circle because -3 and 4 are both not included in the inequality. This shows that A can take any values between -3 and 4 exclusive. Therefore, that a is less than 4 and a is greater than minus 3 can also be written as sandwich inequality, that a is greater than minus 3 but less than 4, as all the values of a's are sandwiched between the two endpoints minus 3 and 4. If, however, a is greater than equal to minus 3, then circle at minus 3 would have to be shaded to show that 3 is included in the inequality. Hence, the sandwich inequality now will be a greater than or equal to minus 3 but less than 4. If a is also less than or equal to minus 4, then we also need to color the circle at 4. Values of a's that satisfy the inequalities are now any number between minus 3 to 4 inclusive. If a is integer value, then a can only take negative, positive, or a zero value. So the sandwich inequality tells us that a can only be whole number between minus 3 and 4 inclusive. If we now replace that word and with another word or, then this is very different problem. The word or indicates that both inequality must be satisfied individually and together. For example, inequality a less than 4 is satisfied by all the numbers that are less than 4. Similarly, all the numbers greater than minus 3 satisfies the inequality a greater than minus 3. And the numbers between minus 3 and 4 satisfies both the inequalities. Therefore, set of numbers that satisfy a less than 4 or a is bigger than minus 3 is all the numbers on the number line inclusive of 4 as well as minus 3. Or basically means the union of all the inequalities. However, we are not able to write such inequalities as sandwich inequality like we did earlier. Suppose you have £50 taxi budget and taxi charges you flat rate of £4 and £2 per every mile. How many miles can you travel without exceeding your budget? If you travel 1 mile, you will pay £2 for 1 mile and flat rate of £4, so the total charge will be £6. If your budget is £50, you can make that 1 mile journey without a problem. Similarly, it is also possible to make 2 and 3 miles journey without a problem. In fact, we can make up to 23 miles of journey with that amount of money. However, we can also solve this problem much more effectively using the inequality rather than guessing. Suppose that the number of miles you can travel with the budget is x miles. Then 2x is the amount you must pay to travel the x amount, since every miles costs you £2. We also need to add the flat rate of £4. Therefore, the total amount you pay for x miles of journey is given by the expression 2x plus 4. However, the total amount could not exceed £50. This is your budget. Hence, the expression 2x plus 4 have to be less than or equal to £50. This inequality can be solved for x. In order to solve this, we now need to isolate the x from this inequality. First, take away 4 from both sides of the inequality. This leaves us with 2x on the left side and 50 minus 4 gives 46 on the right hand side. X is multiplying with 2, so we now do the opposite. So we can divide both sides of inequality by 2 in order to eliminate 2. So this gives us x less than or equal to 23. This solution can be illustrated on the number line. If this mark is 23 on the number line, then x can take any values below 23 inclusive. Since x represents the number of miles, it could not be negative value as you cannot travel negative number of miles on a taxi journey. Therefore, the value of x is bounded by 0 on the lower end and we can write our final solution as a sandwich inequality. This tells us that given £50, we can travel any number of miles from 0 and up to 23 miles. Have a look at this inequality statement. This statement is currently true because minus 4 is less than 8. However, if we divide both sides of the inequality by minus 4, you get 1 is less than minus 2. This statement is now untrue. Therefore, to make the statement true again, we must flip the inequality sign. If we now multiply both sides by minus 3, this gives us minus 3 is greater than 6. We need to again flip the inequality sign to make the statement true, as 6 is actually bigger than minus 3. We need to always make this adjustment to the inequality sign whenever we multiply or divide by a negative number. Beware of this fact whenever solving the inequality question. Consider solving this inequality. On this occasion, our plan is to gather the unknown term f's in one side of the inequality. So we start by adding 4f to the both sides of the inequality, as there are already minus 4f on the right hand side, and adding this 4f will eliminate 4f altogether on the right side and leaves you with just minus 1f on the left side and minus 18 on the right side. We then multiply both sides by minus 1. This gives us f is greater than 18. However, we must remember to flip the inequality sign in order to make the statement correct, as we are multiplying by the negative number minus 1. Let's look at another example. This is a sandwich inequality. We can solve this to find the values of n. On this occasion, our objective is to isolate n from all the other terms. Since 4 is added to minus 2n in the middle of the inequality, we start by doing the opposite, which is to take away 4 from each part of the inequality. Minus 4 and minus 6 gives us minus 10 on the left hand side. 4 and minus 4 cancels out each other in the middle of the inequality and leaves us with only minus 2n. And 12 minus 4 gives us 8 on the right hand side of the inequality. Since n is multiplying with minus 2, in order to eliminate minus 2, we must divide it by minus 2. So we divide minus 10 by minus 2 gives us 5 on the left. Minus 2n divided by minus 2 gives us n in the middle. And we can also divide 8 by minus 2 to give minus 4 on the right hand side of the inequality. Since we are dividing by the negative number, this inequality is currently untrue. Therefore, we also need to flip both sides of the inequality sign. However, this inequality is equivalent to n greater than equal to minus 4 but less than equal to 5 as well. Alternatively, we can solve this inequality by splitting the sandwich inequality into two separate ones and solve them each individually. First, we take away 4 from both the inequalities. Divide by minus 2 and then flip the inequality sign. Then we combine the inequality signs together. Hence, the solution to this inequality is n greater than equal to minus 4 but less than equal to 5.